For decades, science insisted the first Americans arrived just 13,000 years ago, but in central Texas, researchers uncovered over 150,000 ancient tools buried beneath the expected horizon, some as old as 20,000 years. Suddenly, the timeline in every textbook was up for grabs, and the evidence revealed that these sites changed what we thought we knew. So what did the Gault and Friedkin discoveries really prove? And what secrets are still buried beneath our feet? In the early 20th century, archaeologists working in the American Southwest uncovered a distinctive type of stone spear point near a small town in eastern New Mexico. These fluted points, soon named for Clovis, became the calling card of what textbooks would describe as the continent's first widespread culture. For generations, the Clovis toolkit, marked by its elegant grooves and expert flaking, was seen as the signature of the earliest Americans. The date attached to this culture, 13,000 years ago, appeared in scientific literature and classroom maps for decades. The Clovis story took shape around a simple migration model. During the last ice age, massive glaciers locked up much of the planet's water, lowering sea levels and exposing a land bridge, Beringia, connecting Siberia to Alaska. As the climate warmed and glaciers began to retreat, an ice-free corridor opened between the Laurentide and Cordilleran ice sheets, slicing down through western Canada. According to the prevailing view, small bands of hunters followed herds south through this corridor, eventually spreading rapidly across the unglaciated landscapes of North America. For most of the 20th century, any claim of an earlier human presence faced deep skepticism. Sites that hinted at ages older than 13,000 years, places like Meadowcroft Rock Shelter in Pennsylvania or Monte Verde in Chile, were scrutinized for every possible flaw. Critics questioned whether ancient bones or tools had truly been left by people, or if they had been moved downward by burrowing animals, floods, or even careless excavation. In this climate, the Clovis horizon became the evidentiary gold standard. Anything older was dismissed as an error or fluke, unless it could clear an almost insurmountable bar of proof. This tight framework shaped how archaeologists approached new discoveries. The Clovis first model was not just a hypothesis. It became the lens through which nearly all early American archaeology was interpreted. Only in the past few decades, as more sites began to yield credible evidence of earlier occupations, did cracks appear in this once solid consensus. In central Texas, an unassuming patch of limestone country began yielding evidence that would force archaeologists to reconsider the entire story of North America's first inhabitants. At the Gault site, field teams set aside old assumptions and dug deeper than any previous collector had dared. Layer by layer, they worked through the familiar horizon associated with the continent's earliest accepted culture, then pressed on into older, untouched sediments. What they found was staggering in both scale and depth. Excavations at Gault uncovered more than 2.6 million artifacts, by far one of the largest archaeological assemblages ever recorded in the Western Hemisphere. The sheer volume alone set this site apart. But the real surprise lay in what was buried beneath the classic horizon. In these deeper layers, researchers documented a large, well-stratified collection of stone tools and debitage, distinct from the later, better-known toolkit. This pre-Clovis component, the so-called Gault assemblage, was not a handful of stray finds, but a robust record of human activity. Thousands of artifacts, including unique projectile points, blades, and manufacturing debris, were recovered from sediment that had lain undisturbed for millennia. Analysis of the stratigraphy revealed that these deeper artifacts were separated from the overlying layers by clear, uninterrupted bands of sediment. There was no evidence of mixing or downward movement from above. Each occupation zone remained intact, preserving a chronological order. The context and density of these finds suggested a sustained human presence in central Texas long before the traditional timeline allowed. Initial age estimates, based on the position of these layers within the valley's geological sequence, pushed human activity in the region back as far as 16 to 20,000 years ago. The magnitude of the Gault discoveries raised a profound question. If people were living and making tools in Texas thousands of years before the accepted date, how old were the first Americans really? The evidence at Gault demanded a closer look at the methods used to determine the age of these ancient occupations, and set the stage for a new chapter in the search for America's earliest settlers. Along the banks of Buttermilk Creek, just 250 meters downstream from the Gault site, another excavation was underway. Led by Michael Waters of Texas A&M, The Deborah L. Friedkin site offered a second, independent test of the region's ancient human presence. Over a decade of careful digging, Waters and his team recovered a remarkable 100,000 stone artifacts from deeply buried floodplain clays. Among these were 12 projectile points, distinct in form from anything found in the classic horizon above. These tools, now known as the Buttermilk Creek Complex, display a stemmed design that stands apart from later traditions. The Friedkin site's significance rests not only in its artifact count, but in the clarity of its stratigraphy. The cultural layers were sealed within fine-grained, horizontally deposited clays, with no evidence of major disturbance or mixing from above. Each tool, flake, and core was locked in position by the slow, incremental buildup of flood deposits. This geological context provided an ideal setting for advanced dating techniques. Traditional radiocarbon dating, which relies on preserved bone or charcoal, proved unworkable here. The acidic soils had stripped away organic remains, leaving only the stone record behind. To address this, Waters' team turned to optically stimulated luminescence, or OSL, a method that measures the last time quartz grains in the sediment were exposed to sunlight. By sampling multiple depths and locations across the site, and submitting these samples to independent laboratories, the researchers established a consistent sequence of ages. The deepest Buttermilk Creek Complex artifacts yielded OSL dates between 13,500 and 15,500 years ago. Overlying layers, containing later tool types, returned younger ages in stratigraphic order. The results from Friedkin matched the patterns observed upstream at Gault, but arrived at them independently. Here was a separate site, a short distance away, with its own large sample of artifacts, and a parallel sequence of occupations, each dated by the same rigorous method. Together, the two sites confirmed that Central Texas had been home to people thousands of years before the timeline long taught in textbooks. Projectile points from the oldest layers at Gault and Friedkin display a form and craftsmanship distinct from the later fluted Clovis types. The earliest tools, lanceolate stemmed points, appear in sediments dating between 16 and 20,000 years ago. These are not isolated finds, but part of a consistent sequence. In overlying layers, triangular lanceolate points begin to show up around 14,000 years ago, followed still later by the classic fluted points that define the Clovis horizon. This local progression in Central Texas, fixed by stratigraphy and OSL dating, demonstrates that new tool types appeared over time, rather than arriving all at once from a single migration event. The timing of these technological transitions holds implications far beyond the Buttermilk Creek Valley. The presence of humans in Central Texas by 16,000 years ago means people were living well south of the glacial ice sheets before the famed ice-free corridor became a viable route. Geological and paleoecological research shows that this corridor, trapped between the Laurentide and Cordilleran ice sheets, only opened fully between 14 and 13,000 years ago, after the earliest Texas occupations were already established. This mismatch in timing has pushed researchers to consider other possibilities for how the first Americans arrived. One leading model now envisions a coastal migration along the Pacific Rim, the so-called Kelp Highway, where small groups could have moved south by boat, exploiting rich marine resources. Archaeological sites along the Pacific, though often submerged or eroded, lend support to this scenario. Monte Verde in southern Chile, dated to about 14,600 years ago, stands as a southern benchmark for early human presence. Even further back, at White Sands in New Mexico, human footprints have been dated to roughly 23,000 years ago, though those results remain under scrutiny. Taken together, the Texas evidence fits into a broader continental pattern. Early tool traditions in the West, such as the Western stemmed tradition, overlap in age with the pre-Clovis technologies found at Gault and Friedkin. Rather than a single technological ladder or migration wave, the archaeological record now reveals a mosaic of early traditions, each adapted to different landscapes and environments. The sequence of tool types in Central Texas, stemmed then triangular then fluted, mirrors a local evolution, not a continent-wide progression. The data indicate that by the time Clovis technology appeared, people had already been living in the Americas for thousands of years, moving by more than one route, and developing new ways to survive as they went. Today, the Texas evidence reshapes how science frames the peopling of the Americas. As new discoveries surface, every data point challenges old certainties. The first American story remains unfinished, reminding us that even well-settled truths can shift beneath our feet. Share your thoughts below.